Good morning to all of you. And so today we'll be doing, we will start the session. So those of who could not join because of any reason, they will see and the video and they will do the perform the analysis. Although today's topic, yes, so good morning to all of you, a very, very warm good morning to all of you. So today's topic, today is our last, although it extended so long. So it's the last day of that initial workshop, which we planned for 5 days and then it again extended for 2 more days. So today is the last day. And after, today, you will get those, because you consented to get that end of the week assignment for 3 months, which we have been doing for the basic workshop batch. Although there was a slight delay in checking the assignment and in posting the assignment because of the various other commitments of us and the residents. So we are extremely sorry for that. So bear with those delays and, a little bit of uncertainties. And from today onwards, again, we will be starting with the end of the week assignment for the advanced workshop. So there may be a little 1 or 2 day delay or maybe few hours delay. And maybe you also work in an institute where, a lot of other responsibilities are also there. So because of that, so please bear with us. And the second thing is today's session, that is the Two-Way Anova. This is a little bit rather confusing. I could say that we have tried to keep it simple, but still the commands, because for the first time, we will tell you the use of syntax, because the Two-Way Anova, you cannot perform Two-Way Anova without writing the syntax. So you have to write few commands. It's not the commands actually, you just have to copy paste what is already there with some modifications. So just I'm sensitizing you that it may look a little bit complicated, difficult to understand, but I'll go very slow. We have taken 2 examples so that you will be clear, more clear, and the more you read and you do again, then those concepts will get imbibed, because it took a lot of time for us also to understand, and still we are reading it. Still we cannot say that we are through all the concepts. So we have tried to simplify few concepts, but still we are learning few more concepts, because that knowledge is, there is no depth to the knowledge and we all are learning. So that's why I'm starting this session with that background. So this Two-Way Anova, you have gone through this One-Way Anova, where what we do, this One-Way Anova, that was, we used to compare a continuous dependent variable across more than 2 categorical variable. Like if you want to compare a systolic blood pressure across race, which has got a 3 categories, then in that case, we used to have a One-Way Anova. In Two-Way Anova, before I start with the actual research question and assumptions, let's see a few examples regarding mean, because here there will be a lot of mean. We will be talking of a total mean. We will be talking of estimated marginal mean. So let's see what all these means are. So just see this example. So I'm starting with known to unknown. So this is known to you that if there is a group of individual and you measured the cholesterol level of everyone in the sample and you have calculated an mean. So this is the
No problem.
okay. If it is, we thought there was some problem. So thank you. So we measured the cholesterol level here, which we could see all the people in this particular sample, and we have calculated an overall previous situation. So the mean cholesterol level of men in this case is 160, and the mean cholesterol level of women is again 160. So can we say that the mean cholesterol level of these two groups is same? So yes, we can say, because, and for this, if I want to test, here it is 160, maybe it is a little bit different, like 154 and 160, what test I should have used to see whether the difference which I am observing is statistically significant or not? Which test I should have been used? Please type in the chat box. So yes, Dr. Neeraj has added one more thing, that if it is normally distributed, yes, then we could have used independent sample. T-test, Ashish, Praveen, yes, very right. So you know everything now, much more than what we expected. So this was the comparison of two groups. So now coming to the third situation. So based on this experience, I can say that whether there is a different male the blood pressure of the same set of individual. So pair t-test, the essential criteria is that it should have a paired value of the same individual. So that's why that will not be applicable in this case. So what I did, I have calculated the difference, and then this we have seen this question I have already asked. Now if I want to say, if I want to study the effect of another variable, maybe the status of diabetes. So if I want to say whether a non-diabetic male or a diabetic male will have the same blood pressure mean, or if I want to study the effect of literacy, literate versus illiterate, or maybe another variable, that is the obesity, obese versus non-obese, and similar statement for females. So what I am doing, I am taking two independent variable. In the first case, there was only one independent variable which has got more than two category. But if the independent variable, if I have added one more and I am making groups, so in that case, so I have combined the gender and obesity, and I want to see the combined effect of gender and obesity on cholesterol level. So now which test will I apply? So in this case, the choice of the test will be a two-way ANOVA. One-way ANOVA we perform when there is a one independent variable. Two-way ANOVA we perform when we have got two independent variable and we want to see the effect. So that interaction thing comes here. So that's why if you see the command, there is a something of prediction, model, residuals, all those concepts which we learned in linear regression and logistic, that is there in the case of two-way ANOVA also, because the independent variable, they tend to interact with each other, and basically we will be learning about those interactions. So if two independent variable interact with each other, so what is the effect of that interaction on the continuous variable? So that's we see by the two-way ANOVA. So because we have, by taking two variable, now we have got four, because here the third cell where female non-obese will having two categories. Here the both are having two category, male and female. obese and non-obese. Are you clear up till this point regarding the categories, how this combination is working? If we add one more variable to the independent set, that independent variable, because they tend to work together. So now we have got four cells where four combinations will be there. And basically in two-way ANOVA, we test all the assumptions in these four cells only. Four cells means depends on the number of categories. Four cells I'm only talking here because I have got two categories, two independent variable, both having two categories. If one independent variable has got three categories and the other two categories, then total number of cells will be 6. The various combinations, which we will see later, because we have used a BMI category where it has got 3 category, and we have used a gender category which has got a 2 category, right? So depending on the number of categories of independent variable, those many numbers, you multiply the category with each other and that many cells will be there. The combinations of cells, like 3 by 2 ANOVA will have a 6 cells. 4 by 4 ANOVA will have 16 cells. Cells means 16 combinations where in every combination there will be few individual. And then we test. So that's why it will always be we are testing a mean across more than 2 categories, right? Because here ultimately there are 4. So that's why we have to apply ANOVA. But why ANOVA? Because it's a two-way ANOVA, because there are 2 independent variable on that dependent variable. There can be interaction, there may not be any interaction. So depending on that, we report our result. So in this case, you are seeing that the male, just see this slide for a few seconds, and then I'll ask the question. Male non-obese, 120, the value is 120, male obese is 160, female non-obese is 150, and female obese is 190. So we have got 4 combination of category. So can I say that the mean cholesterol level in females remain high across various levels of obesity? If you compare the male and female, can you say that the female obese or the females are having high cholesterol level as compared to men across both these non-obese and obese category? So yes and likely no. So here I can see that, male, if I compare this male obese, non-obese and female non-obese, so I can say that the female non-obese is having more cholesterol level as compared to male non-obese. Similarly, if I compare the male non-obese and male obese, I can say that the male obese is having more cholesterol as compared to more male non-obese. But if we see across the gender, then we can say that the value, if you see the difference, it is 120 and 160. Difference is 40. So that difference is maintained here also. So I can say that gender is having no role here. Why? Because that difference is same across the 2 categories. So even if you don't take gender into account, the result will be the same. In this situation, can you say that the mean cholesterol level in females remain high across various levels of obesity? Just see this. So can I say, because you can you see that females category, if you only of difference, but see, because we can see here that the female non-obese, they are having less blood pressure, they are less cholesterol than the male non-obese. So we cannot say that the female are having high value of cholesterol across both level of obesity. Yes. So did you get this? Did you understand? What is the effect of this second variable? Because in the first, if you see this, even if you don't take gender into account, both male and female, if we don't take gender into account, they are showing the same pattern, that the females are having high blood pressure, high cholesterol as compared to men. If you take gender also, then also that is maintained. There is no, that is maintained that female are having high blood pressure in both the categories, whether they are non-obese or whether they are obese. But if you see this, you cannot say the same statement here, because here you will see that the females are non-obese and they are having less cholesterol than the male non-obese. So we are having again 4 combinations here. So male non-obese, male obese, female non-obese, and female obese, right? So again, in this example, can you say that the mean cholesterol level in female remains high across both level of obesity? Female, you can see female. So male non-obese, female are having high. If you see male and female, again, female are having high. But if you see the obesity, if you see the male obese and male non-obese, definitely the male obese are having high, but it is opposite in case of a female obese and non-obese. Female cholesterol as compared to female obese. So there is a reason for this. So we are seeing the different combinations, permutations, and combinations of it, and it's basically because of the interaction. So in the previous situations, we have seen that the mean cholesterol concentration of female is high than male. That is the main effect. We can call it as a main effect of gender. That gender, because of the gender effect, the mean cholesterol level of female is high. Then the mean cholesterol level of obesity is high. Obese is high than non-obese. So we can say this as a main effect of obesity. And the other 2 cases, there we can say that the mean cholesterol concentration or male and female may or may not be affected by their obesity status. Or other way around, we can say that the mean cholesterol concentration in various category of obesity may or may not be affected by their gender status. So this is called the interaction effect. So there is a main effect of gender, there is main effect of obesity, where you can say that it is high across those categories. And then when you cannot say it with confidence and there is a different interaction occurring by which it prevents you to say such statement, that is because of the interaction effect, because male and female, because the gender and obesity status, they have got an interaction with each other, and that's why you are running two-way ANOVA to see that interaction effect. Is this case scenarios are clear to everyone? We'll again repeat it when we'll see the data, but are you clear up till this point regarding the main effect of gender, main effect of obesity, and what is happening when there is an interaction? So again, to reiterate, if the presence of obesity is not affecting the trend, it is known as the main effect of gender. That means the effect of another variable is not having any impact. So in that case, it's better to report only single main effect of gender. The similar situation with the other thing. If the cholesterol level of are not being affected by gender, even if you don't report gender, it will be same across. I mean, the trend will be same across the category. Then it will be the main effect of obesity, and you need not to report the effect of gender. But if there is an interaction, that means you have to report that interaction, and then you have to give those result and interpretation. So similarly, a two-way ANOVA, today we'll see two examples. In one example, there is an interaction, and in another example, there is no interaction. So we will see in which case what to report, because that is very important. The SPSS gives you all sort of tables, so many tables, and then you are confused which to report and which not to report. And we have gone through several literature, and there is a difference of opinion what to do and what not to do. So we have taken few reference book, and definitely that learned as a reference to tell you the point. So you may find it that it is a little bit different what has been quoted in the various literature, right? So now in this case, coming to the mean. So how many means you can calculate in this data set? So kindly see this for a few seconds, and it is requested from all of you. I mean, whosoever is attending, kindly write that number of means in the chat box. So Praveen is writing 2. So that 2 will be maybe male and female. That's what you are writing. So yes, Neeraj is right. It will be 3, because there will be male, there will be female, and then there will be overall. So don't forget overall, which we saw in the first slide. Remember, we started our presentation with the overall mean. So that overall mean is important. So you should calculate 3 means here: 1 male, 1 female, and 1 overall. So now, if the answer is mean cholesterol of male, mean cholesterol of female, and overall mean. In this case, how many means can you calculate? And what all combinations? So 5, 6. So the idea is first have number of cells, each cells. So how many cells? It will be 2 by 2, so it will be 4 cells. So it will be, and there will be an overall. And again, there will be various other combinations, like there will be mean cholesterol of male, mean cholesterol of female. That will be the one. Then mean cholesterol of obese, mean cholesterol of non-obese. 4. Then mean cholesterol of all those 4 combinations, right? So you will calculate, and then overall mean. So you will calculate across gender, you will calculate across obesity status, then you will calculate the mean of combinations: male obese, male non-obese, female obese, female non-obese, and then overall means. Yes. So there will be total of 9 means. So did you get this? How many means we calculate in this case? So there will be a overall mean, there will be a mean cholesterol of male, mean cholesterol of female, there will be mean cholesterol of obese, there will be mean cholesterol of non-obese, and then again the cholesterol levels of combinations or the cells which we talked, that depending on the number of categories, you have number of cells. So you have got 4 combinations here, so mean of all those 4 combinations, and then again a overall mean. So with this background, so you can say that there are so many means, and once we see the output, you will see that you need to see it very carefully which mean it is reporting. Okay, so in the research question, This is the same research question which we have used for one-way ANOVA. I have just added another independent variable. So the first question is the difference in average BMI score across various races is affected by gender or not? So I have added another modifying variable, or we can call as a moderator variable here as a gender. The second research question there was, is there any difference in the post-operative pain score across surgical technique 1, surgical technique 2, or surgical technique 3 across gender? Again, I have added gender as a variable here in the independent variable. The third question was that student satisfaction level differs with respect. It's a categorical variable. I have divided it into more than 8 hours and less than equal to 8 hours across various teaching techniques. So I have added one more variable, that is the lecture, demonstration, and case-based learning, to see the interaction of various teaching technique on the student satisfaction level. And the primary, the main variable, the independent variable, was the number of hours of study. So now this is another one, this research question again, that if a researcher wants to see the effect of a drug to lower cholesterol level in low risk and high risk elderly patient, and if he has added another factor, and that another factor was that risk status. So if he has added the low and high risk elderly, and then he is seeing the effect of cholesterol, then again, like you have seen the gender versus obesity, there will be again 4 groups, because there will be a control group with low risk, control group with high risk, experimental group with low risk, and experimental group with high risk. So you can see that again, we have started with one independent variable with the addition of another independent variable, that is the risk status of those elderly, low and high. That has been again dividing it into the 4 cells. Cells which we talked, what are those cells? Cells are basically the combinations of those independent variable. So now what we have observed in all this case, that there is a scale variable in each research question, and I want to compare the mean of this across 2 or more category in presence of another categorical variable. So I want to see the interaction of 2 independent variable on one continuous dependent variable. So the appropriate test for this is a two-way ANOVA, which is also known as a factorial ANOVA. So because it's a cell, we make out of that category, we make cells. That's why we call it as a factorial ANOVA. And in this case, there can be 2 possibilities. There will be one possibility where there is an interaction effect between the 2 independent variable on a continuous dependent variable. That can be one case, which we will. Case would be there won't be any interaction. So we have to take the decision based on whether the interaction is present between the 2 independent variable or not. Based on that, we will see what to do. So now, underlying assumptions is the choice of the study design. So there are 3 tests which are the depend on the choice of study design, and there are 3 assumptions which we check on the what we say on SPSS statistics. So this underlying assumption is, the first one is again dependent variable should be continuous, and then the independent variable, which is known as the factors here. So the independent variable having a 2 or more category. If it is having a 2 category, we call it as a dichotomous. If it is more than 2 categories, we call it as a polytomous. Then the third is the independence of observations. So by this time, we know what do we mean by independence of observation. That means if you have taken one person in one category, he will not be there counted as a, like if you're taking one person as a control, he will be there in control, he will not be there in the cases. So similarly, that's the study design issue. Then the fourth assumption is there should not be any significant outlier. Here, I will not say across category. Here, I will say in any cell of the design. And that we will see how to check for that. So all the three assumptions like normality, outlier, and homogeneity of variance, these three which we use to test in ANOVA and this independent sample t-test also. So in that case, it will be tested for each cell of the design. And you know that what do we mean that outlier? By this time, you know that more than 1.5 box plot is the normal, extreme is more than 3. Again, the dependent variable, if I have to see the normality, it is a QQ plot, and Shapiro-Wilk. There are other more like kurtosis and this skewness also, but generally we see either the QQ plot, and if sample size is less than 50, we see the Shapiro-Wilk. The value of Shapiro say that it is normally distributed. Similarly, this homogeneity assumption, we check with the Levine test of homogeneity. And in this case, if the value, p-value of this statistics is more than 0.05, then we say that the assumption of homogeneity of variance is met. So this is again the recapitulation of the previous concepts which we have read. And now coming about the interaction effect. So I have repeatedly told you that we see, because there are two independent variables, so we see the effect on the dependent variable of the interaction. So this, how do we define an interaction? So an interaction is the effect of one independent variable on a dependent variable, and it depends on the level of other independent variable also. So what to do if there is an interaction? So if there is an interaction and the interaction is significant, so if the interaction, see, there will always be an interaction. If in population, if there is a gender and if there is a obesity, so there will be an interaction. But we are saying whether that interaction is significant or not, that we see by the p-value. So by saying that interaction is not there or there, what I mean about that underlying hidden term is significant. If I say that there is no interaction, that means there is no significant interaction. If I say that there is interaction, that means there is significant interaction. By saying this, I will never mean that there will be no interaction. There will be interaction, but since it is not significant, so I may say that it is not there, but please don't think that interaction is not there. So interaction effect, we are only defining in terms of its significance level. If it is significant, we report simple main effect. And there can be two possibilities. Either it will be significant or it will be non-significant. If it is significant, then we report simple main effect. What do we understand by simple main effect? That we will see. In simple main effect is basically we take account of the presence of the another independent variable. So that is the simple main effect, and it is expressed along the category, along both the categories. So we will see the simple main effect of is on the dependent variable. And in this case, the effect of IV is independent variable. I have just shortened it. So the effect of independent variable is different for each level of other independent variable. But when the interaction is not significant, then we report main effect. So there are two terms, simple main effect and main effect. So by saying simple main effect, I mean that the interaction is significant, and then the effect of this independent variable is different for each level of another independent variable. But this, if the interaction is not significant, then we say that we don't need to report the effect of interaction, and we will report the main effect. And in this case, this effect of independent variable will be same for each level of other independent variable. Like you have seen in the case scenario 2 in the beginning, I discussed about the gender and obesity. So in the second case, you have seen that because of the gender, the pattern of obesity was, the pattern of cholesterol across the various obesity level was not being affected. So that was the main effect. But when it is getting affected, then we call it as a simple main effect. The term is a little bit confusing, why we call it as a simple and why we call it as a main effect, but that's the terminology where you will find everywhere. So that main, when it is not significant, we call it main effects, because I was also why we call it as a simple main effect, and why main effect. So by adding this word simple, that means that effect of the another variable is there on the dependent continuous variable. So now how to determine the interaction? So for determining the interaction, we see the tests of between subject effect table. This will look a little bit theoretical to you now, but we will discuss this in detail. Oh yes, maybe Dr. Neeraj is right. S for simple and S for significant. Yes, that's a mnemonic which we can remember. And maybe some underlying facts also. So how to determine this interaction is we have to see the statistically significant interaction effect from the test of between subject effect table, where that interaction term is there. And interaction effect, then we do not report main effect. Means if the interaction is there, then we present the table of that interaction and we don't report the main effect, rather than we report the simple main effect. And there will be two simple main effects. One will be for male and one will be for female. If it is related to, if the other variable is gender. If the other variable is something else, then you can replace that other variable here. And in this case, it separates out the effect of male and female for that particular continuous variable. So it will give you a separate male and female table, taking the presence of the other independent variable and then distribution of that continuous dependent variable. So this case, I think this I will not discuss here. I'm just leaving it. So if there is a no, or rather if there is an interaction, so let's discuss this here. So there is a plot. We draw a plot on which we draw this interaction. So can you see this? There are, maybe you can just think that this is the three category. I mean, these three lines, these 3 points, these two are, sorry. So if the plot is something of this sort, where they will tend to meet somewhere. So if you draw, I mean, if you draw a line here, or if there is some point, so you can say that they will meet somewhere. So these lines are not parallel and these are crossing each other. So if the plot is something of this sort, then we can say that there is interaction. We define 2 types of interaction, ordinal and disordinal, but don't go into the category of this ordinal and disordinal. You just remember that if the lines are not parallel, then there is an interaction. So in this case, you can see that both the cases, here also it is not parallel and here also it is not parallel. So the graph will be something of these sort of pictorial representation where the lines won't be parallel. So if the lines are not parallel, then we call that the interaction is significant. And if the lines are parallel, then we say parallel means they are not going to meet. That means there's no interaction. So there is no statistically significant interaction effect. So I'm saying that interaction effect may be there, but it is not statistically significant. In that case, report main effect. So main effect is basically averaging the simple main effect. It's the main effect. And then if main effect is significant, then we do the post hoc analysis. And it shows that only one independent variable is having an effect on the continuous variable. And in that case, we ignore the presence of the second independent variable, because it will be same in presence of the second independent variable also. So this two-way ANOVA, it is, I think we have done this, so it's just the repetition. We do it. So now we'll see it in the SPSS. So in the SPSS, I've said that we have got two examples. So I'll go with the first question. So let me open the first question. So this is the question. A researcher carried out the study and found a statistically significant effect of mean systolic blood pressure across 3 BMI categories. I think you have done that in the one-way ANOVA. The 3 categories of by BMI are normal, overweight, and obese. He or she recorded the age, gender, height, weight, and SBP of 193 cases. And the BMI scores were calculated. Now the researcher want to know that the variation in systolic blood pressure across these 3 categories, is it affected by the gender or not? So I will add another variable of gender. The continuous dependent variable will be the systolic blood pressure, and the main variable will be the category of, main independent variable will be the category of BMI. So this is the question. Now coming to the data sheet. So now before I start, I will do the assumption testing. So assumption testing, we did that 3 assumptions based on the study design. The first assumption is that the dependent variable should be continuous. So this systolic blood pressure is continuous. Independent variable should be categorical. It can have 2 or more than 2 categories. So BMI cat is having 2 categories. And then it is independence of observation. So that's a study design issue. So I think I'm assuming that that has been met. Now coming to second and the fourth one. So what was the 4th, 5th, and 6th? The 4th, 5th, and 6th variable was, assumption was that we were checking for the normality, homogeneity of variance, and outlier. And for that, what we discussed, that we have to do it across the cell. Across the cell means I have to create those many cells. So for that, so third is the independence of observation. So for the first 3 is the nature of the dependent and independent variable. The third is the independence of observation. And the fourth one is the 4th, 5th, and 6th are the outlier, normality, and homogeneity of variance. So if for that you need to split your table, this across the gender and this independent variable, the BMI cat. So you need to split the group, then only you will have that cells. So for that, we are doing it for normality testing. So before doing that, I will show you that we have to see the interaction. So for interaction, I will go to analyze, and this we go by the general linear model. So general linear model and univariate. So because I've said that, so I will reset this. So this is the dependent variable. So what will I shift here? So dependent is systolic blood pressure. It's a continuous. Now you will see that there is a fixed factors. So we will shift this BMI cat because that was the initial variable, and then I have added gender to it. So this fixed factor is for the independent variable, and this fixed factor we have shifted 2 variables, that is the BMI categories and gender. Now coming to the option of plot, because I said that we need to see whether there is a interaction, significant interaction between these factors or not. So I'll come to plot. If you come to plot, you will have this window. So what you do, shift this to this. So this separate line means that you want separate lines for gender. You can have again the separate line for BMI category and then add it and then continue. So you will have two plots. You will have one plot where there will be separate line for gender. You will have one plot where they will have separate line for BMI category. So just enter like this. What I did, I moved this to horizontal and I have changed this. So one separate lines I want for gender and one separate lines I want for BMI cat. So I have given the command of two plots by pressing this option add, and then I'll press continue. Now coming to this option. So in option, I want to see this. Can you see this variable BMI cat? There's a star and gender. So this tells you about the interaction. So I just want to check first whether there is any significant interaction or not. And then I will move this. And then I will see the descriptive and homogeneity of this significance along with this p-value. I'll press continue. I have to check again one option here for the this residual. So I've told that this two-way Anova, it predicts the value of standardized, unstandardized, and studentized residual, because I have to check the three assumptions. That is the linear, not linear, sorry. That is the box plot, normality, and Levine statistics. That is checked on the residuals. That is the difference between the predicted and the actual value. So you click these three: unstandardized, standardized, predicted value, unstandardized, then unstandardized residual, and then studentized. So this, press continue. So I have clicked three options, right? I have clicked plot. I have clicked this option where I have entered this into this display mean. So am I audible to all of you? Any problem with the voice?
No, ma'am, it's audible, ma'am.
Okay. And then I have clicked this option of save, where I have clicked this option of save only because I want to have these residuals for checking my three assumptions, right? And then I have pressed this continue, press this OK. And then it will lead to the output. Again, if you see the data of three variables that we have seen in the linear regression and logistic also, where we used to click this predicted value, residual, and studentized residual. And if you see the output, in the output, what you can see that this is the univariate analysis of variance. This is the descriptive statistics. It is giving you the overall mean. It is writing, and then if you come down, this gives you the Levine test of equality of variance. So this, you can see that the variance, this value is more than 0.05. And now the focus on this table. So I will focus now only on this BMI cat gender, right? So if you focus on this, can you see that this value, the significance, focus on this significance, it is 0.671. So this interaction, if you see the p-value of this interaction term, this gives you the interaction of BMI category and gender, then this is not significant. So if this is not significant, what will I do? So what I will do, I will only report the main effect. Recall that flow diagram where we discussed that whether that interaction effect is significant or not. If the interaction effect is significant, we report simple main effect. And if the interaction effect is not significant, we report the main effect. Main effect means we will report the effect of this BMI category and gender. And you can see here this value. You can see if you focus on this 0.207, this is significant. That means the value of this systolic blood pressure is significant across the BMI category. But you will see that this gender is not significant. So that's why this overall interaction is also not significant. So that means we have to carry the simple main, we have to report the main effect. And this is the profile plot. I'm not discussing this right now. We will go down. Now see the profile plot. So by the seeing this profile plot, what this profile plot is saying. So it is, this profile plot is saying that there is some interaction because the lines are not parallel. Category of BMI, it is saying that because of that obesity, there is some significance. So, but again, just don't go by this profile plot, because if you see the profile plot, it will say that this is significant. But actually, if we go by the objective way, because the p-value is a more objective way of saying that this whether this interaction is there or not. So this says that there is not a significant interaction. That's why we will report the main effect. We will not take the simple main effect. Now, if the interaction is present, even if it is not, then we will go for the assumption check. So for the assumption check, I have clicked these values. Remember this predicted and the this studentized and unstandardized residual. So for that, I need to check the value of these across the cell. So I will go splitting my, so I'll go to the data, I'll split my file. I will compare the group based on the BMI cat and gender. So it will have a comparison, that cell formation by this, and then I have pressed OK. So if I have pressed OK, you will see that there will be appearance of command here, and it will be writing that it is split file layered by BMI category and gender. So that command you can see, and if that command appears, that means that that command is successful. Now you have to do the assumption check of the normality, box plot, and the homogeneity of variance across cells. There was one homogeneity of variance which was appearing in the table, this table also, this one. But the more important is to report it across the cells. So for that, so that is again the same variance, I'm sorry. And then you go to descriptive, explore, and in explore, what will I do? I'll click this plot. I'll shift this residual to here. In this plot, I'll uncheck this, check this normality plot with test, press this continue, press this OK, and then see this. So this was again, we have done it so many times. So here you can see that it is the Shapiro-Wilk value. So we don't use this, you see the QQ plot. So there will be 6 QQ plot. So you can see here, we'll go one by one. It is the one category is the normal female. So this is the QQ plot of that. If you go down, there will be category normal male 2. Then you go down, it will be overweight female, and then overweight male. Then again obese female and obese male. So you have got 6 QQ plots, and then again you have got 6 box plot also. So if you go down and see the box plot, you have got 6 box plots. So this is one box plot, no outlier, no outlier, no outlier. There is one outlier, case number 143 here. Again, no outlier. So this way, you can see that you have checked for the assumption regarding the outlier in the all 6 cells. So here we check the assumption by giving the command split. Why? Because the split, this will create 6 cells, and then we have to check the normality of the residuals across these 6 cells. So are you clear up till this point? How do we check for the normality and variance and
मैम
this
एक बार स्प्लिट वाला कमांड से एक बार फिर से बता दीजिए.
स्प्लिट के लिए उसमें क्या है कि आप जितने भी वेरिएबल इसमें डालेंगे, you go to the data, it comes in data में you go to split file. This dabba, this box na, you can enter one more variable also, so it will create those many combinations of cell. So the basic purpose of splitting is you are creating a cell. So basically, if I don't create, it is like this. But if I write this, analyze output by groups, see, there is one more option of compare group that we use at some other place. I'm not telling you. Here we organize output by groups, means it will create those many number of cells like BMI, cat and gender. So it will create. So that be error. I mean, we also to constantly saying that this is by group. So don't, after checking the assumption, don't forget to uncheck this. So right now, because I have come, you have brought me here, so I'm unchecking this now because I may forget. So then I press this OK. This OK, again, it will show you that there is a command which will show that split file off. All the commands which you perform on SPSS, it writes that in the background. So that if you see this also na, it will be, and here also if you see this column, it gives you, like if you want to go exactly to something one, it is something of an indexing specific thing. If you want to see, you can go like this also, right? So this you can see here. So split file is now off. So now I have checked for the assumptions. I have checked for the interaction, which was the most important thing. And interaction, I've said you that subjective way and there is an objective way. Subjective way, when you see the plot, it should not cross each other if there is no interaction. But the more objective way is to say that the p-value is more than 0.05. So if the p-value in that between subject ANOVA, that table which we have seen, if it is more than 0.05, this one, test of between subject effect, if it is more than 0.05, then we say that there is no significant interaction present between the BMI category and gender. Are you clear up till this point? Then I'll go one step ahead. Or do you want me to repeat any commands or repeat any concept or anything up till this level? I mean, at this point. Okay, so if it is clear, so what do you want me to repeat? Can you please specify? Repeat everything? Interpretation, okay. Interpretation, what I did starting from the command. The most important thing for me is to check for some other. I did independent variable systolic blood pressure here. The independent 2 variable in the fixed factor, I have clicked this option of plot where I have drawn 2 plots. It is a subjective way of seeing the option. So if you click this interaction term, so I have clicked this display option, save option. I am not telling this. I have clicked for checking the normality box plot because I check it against the residual, and then I have given the command of OK. I'm not pressing OK because again it will have another set of PRE, this residual and studentized residual. Every time you give the command, it will create 1, 2, and 3 set of PRE, residual, and SRE. You must have observed this also while you perform the analysis, and then you press OK. So if you press OK, it will lead to an output which will show you the first table is it starts from here. You can see here the commands which you have given. So I have given the this univariate analysis by BMI category, and then this intercept. Oh no, this is some other command. Sorry, this was the command of this. By seeing the command also you will learn. So my command, yes. I'll go again down. I have come up. So this was there. So this was split file. This was statistics compare group box plot. This I have done. Again, I have, if you come here and see this, so where was that table? Before this analysis, let me, yes, it is here. So if you go up and see this is the test between the subject, right? So here you can see that there is a significance. You have to focus on this significant table, and you have to see that whether this gender and BMI interaction, if it is what value of significance it is leading. So if you see here, it is showing you 3 value. Like, let me show you the another this thing. Now focus on these 3. Focus on these 3 first. There is an effect of BMI category. This table shows you the effect of independent variable BMI separately, gender separately, and interaction between BMI and gender. So BMI category, if you see, it is giving you a significant value. Gender, it is not giving you significant here. That's why this BMI and gender is not significant. Why? Because with the presence of another variable gender, this interaction is not significant. So if this interaction is, you have to report this in your result that this interaction was not significant. That's why you are reporting the main effect. Main effect means you will be reporting the estimated marginal mean of systolic blood pressure across the various BMI category and various gender category. That we will see. So are you clear that why this interaction is not significant? This interaction is not significant because I have taken this p-value, and the p-value, it shows that it is more than 0.05. That means this interaction of BMI category and gender, it is not significant. It's not significant means that the presence of gender is not affecting the distribution or the value of systolic blood pressure across the BMI category. That trend is maintained. So that's why it is not getting affected by presence of gender. That's why this interaction is not significant. So just report this. We will see it in the analysis and interpretation. Report this, that the interaction is not significant. Report the other assumptions that we have checked it, and again, then we will go to the reporting main effect. So if you have understood up till this point, because from this point, the analysis is divided into two parts. If I have to perform, if this interaction was significant, that we will see in the another scenario after this, in that case, I would have run the syntax, which I will not do now. Why? Because there is no interaction. So I don't need to run that analysis. I will go through the pairwise comparison and post hoc, which we will see. So is it clear up till this point about the checking the first and most important is to check whether that interaction is significant or not. If it is not significant, then we will go to report main effect. Main effect, what do I mean by this? That there is no effect of gender per se on the distribution or the value of systolic blood pressure across BMI CAT. So we will report the main effect of gender on systolic blood pressure and main effect of BMI CAT on systolic blood pressure. So we will have two tables, right? So is it clear to you? Now somebody may say that why cannot I perform two separate one-way ANOVA? So for gender, you don't need to perform one-way ANOVA. That you will perform an independent sample t-test that we said. But in this case, because I said that there is some interaction that is not significant, but although that interaction is there, that's why you go for this two-way ANOVA, because two-way ANOVA gives you the estimated marginal mean. It is less than 0.05. The cutoff is 0.05, Dr. Praveen. So it is more than 0.05. That's why variance not met. Yes. It's Levine test is more than 0.05 value. So are you clear, Ria and other participants? Any ambiguity up till this point? I'm going very slow. You may find it a lot of repetition, but still that is needed. Otherwise, okay. So if interaction is significant, then now I'm going to perform report the main effect. Main effect means I'll report separately for gender and for what? For BMI CAT. Now another question, like I said, you may ask, why I will perform one independent sample t-test for gender and one ANOVA for BMI CAT. Can you do that? Say yes or no. So if I go by two, like what I could have done? I could have reported gender, distribution across gender, right? I could have taken male, female, put the mean value of both the systolic blood pressure across two categories like we have been doing. And I could have done, and we did this, right? In our previous exercises, we did like this, that we applied independent sample t-test across two categories. And if it was more than two categories, we applied ANOVA. That's how we learned. But in this case, even if the interaction is not significant, it doesn't mean that there is no interaction. Are you getting my point? There is always some interaction, but the reporting is different, because in this case, you will see that the mean it is reporting, it is different from what you get in one-way ANOVA. So you can do that. That's a homework for you. You do it by one-way ANOVA and you do it by two-way ANOVA, and then see the mean value. It will be different. It will not be the same, because the means it is reporting, it is the estimated marginal mean, and this estimated marginal mean is the combination of both the variables, right? So that's why this two-way ANOVA we are doing it. There has been a lot of discussion. I mean, if you read literature, a lot of people also ask, why can't we perform two tests, one separate independent? And if it is a 3x3 ANOVA, means both having three category, then also they will say that I'll perform two ANOVA independent rather than two-way ANOVA. So that will be a different objective. But if you want to see the interaction, then you need to go with this two-way ANOVA. Even if there is no significant interaction, the estimated marginal mean, that because this option of generalized linear model, which you see here, this, when we go to this analyze and GLM and univariate, it gives you the estimated marginal mean, which is the combination. It takes into account of both the variable. For right now, you understand this, that the mean which is reported from the the mean which is reported from the ANOVA and which is being reported from the two-way ANOVA, they are not the same, and it's a homework for you that you do it. The same question, performing two tests, one independent sample t-test for gender and one-way ANOVA for SBP category. Sorry, for BMI category. Okay. So if you have understood up till this point, then I'll go a little ahead. And then what I'll do, again, I have told you that please, this command split, please uncheck this, because if you don't uncheck, if you have forgotten this, again, it will lead to a wrong analysis. So don't forget. And again, uncheck this also, that are predicted and studentized. Otherwise, it will keep on giving you the so many. So what I'll do, in this save option, I'll uncheck this, because the more I run this, the more set of residuals it will keep on creating. So if you have understood up till this point, now I am performing the main effect. So for main effect, what I'll do, again, I'll go to the same option, analyze general linear model, univariate. This will already be there because you have shifted these variables here. Plot, I have already checked for plot. So you may uncheck this. So either you may cancel it or you will have another set of plot. So that's up to you. Then in the option, now what you have to do, you want this estimated marginal mean. Is it clear? So you want estimated marginal mean for these three. So you will move these also here. So you want the estimated marginal mean for BMI category and BMI gender. You can again move it here back. Why? Because this you don't want. This interaction, this will give you, you are having a simple main effect. But no, just leave it here. We will again see. And then we have to compare the main effect. So click this main effect. This main effects give you the main effect of BMI cat and BMI gender. And then you click this Bonferroni and this descriptive and homogeneity, just it's continue. And this will give you the comparison, right? This option, this compare main effects, this gives you the pairwise comparison also. So now I'm not clicking on this post hoc because that will create confusion to you. So only I did that, I have clicked this save option, I have unchecked this. I press continue and this option, I want estimated marginal mean separately with main effect of BMI cat and gender. So I'll press continue and I'll press OK. So if I press OK, you will have this. So it is the estimated marginal mean of BMI category again. So it's the mean is 137, 147 and 153. You report this with its confidence interval and you report this pairwise comparison. So here you can see that the difference between the normal and overweight. So this gives you the, here it is the only the main effect of BMI. Remember, this is main effect of BMI and it is giving you the difference of that we have done previously also. This pairwise comparison. So this gives you the normal and obese, and this negative sign you will see that this minus and plus, this only tells you whether you are deducting I from J or which variable you are taking, which is the high. So these are the multiple, this is the comparison. Then again, this is the, it is significant. Then this is the simple main effect of gender. So if you see the simple main effect, this tells you that this systolic blood pressure, it was 149 and 142 in the male and female group with its 95% confidence interval. And it says, if you come down, it will give you the pairwise comparison also of male and female. It tells you, because pairwise comparison is not, it will not be too many comparison because there are only two groups. So it will only, the difference between the male and female is only 7. And then this gives you this one. This gives you again the across the normal female and normal male. So it gives you again the pairwise comparison. And this is the profile plot which you have already seen. We have checked it. So now how to report this? So again, I'll go back to the this interpretation. So if you come down, so the question is, does the mean SBP differs across the different BMI category? Yes. This also appears different across the different gender category. And is there any interaction between the BMI category and gender? So answer of this will be no. This will be yes. So if you go down, so this is the analysis of, so I'll show you in the parallel way, factorial analysis of mean systolic blood pressure across different BMI levels and gender category. So if you see this is the 143.7 with its standard deviation. That is there from the descriptive. You can see, I'll go up and there you can. So this is this table. This is the normal, male and female. This is the underweight. So this descriptive along with its standard deviation and total. This total is this one, 137 plus 33. So this, you will report this descriptive table and then you will report this test between subject. So test between subject, this is important. And here you will show that significant value, that it was significant, but these two were not significant. This interaction was not significant. And then you will show the pairwise comparison across various BMI category. So you will show this, and then you can show one more table that we have not kept here. That pairwise comparison of mean SBP across BMI category, and then pairwise comparison of mean SBP across gender category, because you need to report two main effect that we have seen. So here, this also you have to report that gender, that is missing, but this also you will report. This one, this pairwise comparison. If you again go down, this one, right? So you report these two pairwise. So how many tables are we going to report? We report one, error between subject, where we'll show the interaction term, whether it is significant or not. We'll report one table of descriptive, and we'll report two pairwise comparison, right? So these are the four tables, and this profile plot, again, it depends. If you wish to report it, then you have to modify it. We can't keep paste it simply. But again, this is the one which you need to report. So if you are clear up till this point, then let me read the result also, not me. One of you may read it. So I'll go down. This is again the same pairwise comparison and 95% confidence interval. You can see that the difference between overweight and normal, it is the, if you see the confidence interval, this is only the obese and normal is significant. Otherwise, rest are not. So this is the statistical result. So interpretation, please, one of you can read this. You see these interpretation because these slides will be with you, and this Word file will also be with you. So you can see them again in your leisure time. But again, just for having a revision, it is requested from one of you to kindly read it for us. No voluntary. Shruti, I'll ask you to read.
Yes. A two-way ANOVA was conducted to examine the effect of gender and BMI category on mean SBP. Outliers were assessed by inspection of a box plot. Normality was assessed using a QQ plot for each cell, and Levine's test was assessed for homogeneity of variances. There were no too few outliers.
I have written few only because there was one. So that
Sorry.
it was like, you can say there was one outlier.
And there was homogeneity of variance as suggested by p-value is equal to 0.481. The interaction effect between gender and level of BMI on SBP was not statistically significant. F value with degree of freedom 2 and 192 was equal to P1 or
I think there is some.
indicated that the
I think voice is breaking.
is
Issue with the connectivity. Shruti, we cannot hear you clearly. So I think this, you can see this, so we could see what she read. This is again to emphasize that it was the main effect which was performed. And again, that main effect, you have to say that pairwise comparison you run and you have reported the mean systolic blood pressure. So this you will explain both the tables like you have explained for the pairwise comparison in the one-way ANOVA. So you will do similarly here also, the pairwise comparison of the two tables. So remember, we have to write the pairwise comparison of two tables here. Pairwise comparison of this, not this one, sorry, this you don't have to report because this is for the interaction. So you will come here and you will report this gender plane, and then you will report this pairwise comparison of the BMI category. Okay. So if you have understood up till this point, then we'll go to the second example where there was a significant interaction. So in that case, what to do? Okay. So now I will go again with the second example, and the second example was, so the question is, a researcher enrolled 193 patients in 3 intervention arm, that is a placebo, diet modification and drug, and he found a statistically significant variation of mean cholesterol across 3 intervention level. Now he wants to know whether the variation of mean cholesterol across intervention level is same across gender categories. That means whether there is any interaction between the gender and the various category of intervention or not. So for that, what I will do, I will again go and check for my interaction. So the first thing, it is for checking the interaction. So I'm deleting this. Even if you don't delete that, I have unchecked that. There's no problem. I have unchecked that command. This other thing, like checking for normality and outlier, splitting the file, then making the splitting command, that is same here in the case of if the interaction is there or not. So this checking for assumption is same for both the sort of analysis, whether the interaction is significant or whether the interaction is not significant. So in this case, I have to check the value of cholesterol. So I'll go to the analyze. I'll go to the general linear model, this univariate. I will move this to here. And I'll move this cholesterol to, okay, so it's the cholesterol 2 variable, yes, this one. So let me delete maybe the first one because it might create confusion to you. Or let it be, maybe for some other purpose we can use this. So this cholesterol 2 is the variable which I have to take. And then I'll move this BMI category here. Again, this because I have to do it across intervention in presence of another variable, that is the gender. So are you clear what we moved here? Again, similar to the previous command, this dependent variable, this is cholesterol 2. That is the variable which I have named, which I have to take. And then in this independent variable, I have to see it across 3 interventions. And I have to see whether there is a presence of, there is an interaction effect of gender or not. So for that, what I'll do, I'll go to this option. In the option, I'll move this and I'll see this is already ticked. And then I'll go to this plots. What I did, I have moved this and this gender. I want separate line, then I press add. Then I have moved this gender. I want separate line for my intervention. So I have moved this and I have kept it add and then continue. I am not checking for this predicted and residual because this process will be exactly same the way it has been explained to you in the initial assumption testing. So that you can do. Again, we have to do it, but after this you have to split the file based on the 2 groups. So don't remember, and after splitting the file, don't forget to uncheck that splitting, right? So these 2 things, I'm not checking it because again, it will create another, like I told you, SRE and PRE. And then you press OK. So if you press OK, it will lead to a descriptive table, this Levine's test. And then so Levine test, you can see that homogeneity of variance, it is not met because this value is less than 0.04, but this is borderline. So we can go for like, that is still there. And then you can go for this table. So this is most important. So if you focus this here regarding the, what we say, that interaction. So if you can see here that both the 3 terms are significant here. This interaction is significant, gender and intervention. So now you have to report the simple main effect. So to report the simple main effect, you can't perform it by simple giving the commands on SPSS because in that case, what you have to do, again, you have to go to analyze. General linear model, univariate. In univariate, you can see that this is there and we have clicked that option. Now click on this paste. If you click on this paste, it will lead to a appearance of a syntax file. So let me delete this syntax otherwise. So it will lead to appearance of a syntax. So this is a syntax file which has appeared here. So in the 6th line, you will see 1, 2, 3, 4, 5, where you can see an estimated marginal mean. This you forget because, or let me delete this. Otherwise, you will get confused. This was from the previous command which I have executed. So maybe I will do it like this. So it will come something of like this. So this is EM mean. So can you focus on this syntax? Actually, this, when you give the paste command, it will lead to a syntax means on the background what this software is, what commands the software is running. So that will lead you to that page if you press that paste option. So if you give this, if you see this, can you see this EM means? Everyone, please focus on this EM means. This gives you the other things like intercept, plot, print, criteria, alpha, design, something of that sort. But focus only on EM means. Can everyone see this in the syntax? Please type yes, no, otherwise I'll repeat once again. I'll repeat all the commands. Okay. So if you can see this, then what I need to do, it is giving you the syntax of this intervention, but I want the simple main effect. The simple main effect means the effect of gender and BMI cat separately also. So what I'll do, I'll write here, compare. So give one space and press C. If you press C, it will lead to compare. it will lead to compare. Now I want to compare what? I want to compare gender separately. So I will write here, first I will write intervention. And then I'll close this bracket. And then again, I have to do that pairwise comparison, this with Bonferroni adjustment. So I will write ADG. If you write ADG, it leads to this adjustment. And then again starts with bracket and write Bonferroni. And then again close this. Sorry, this. I need to write this Bonferroni. And then I have closed this bracket. So this was one. So I now want to compare this simple main effect across intervention. Again, copy paste the same thing in the next line. And then instead of this intervention, now I want gender as a separate one. So gender. So see, gender is from G capital. So you see, write it carefully, gender and then this. So this is now your syntax is ready and then you have to run it. Okay. So this command you have to write separately or you can copy paste it. It's only the compare and Bonferroni. In the bracket, this compare and the bracket tells you that it will lead to the estimated marginal mean taking intervention as a simple main effect. And this will give you the estimated marginal mean giving gender as a separate effect, separate main, simple main effect. So this EM means tells you about the estimated marginal mean. And because this mean, you should report it with correction. That's why you have applied this Bonferroni correction. Then come to this run. And in run, just press this option all. If you run this option all, then again it will lead to a. So here you can see your command. It is writing that you have given this command of EM means tables, compare, etc. This helps you to look in the output because if you are performing Two-Way Anova, there will be a lot of tables. So if you see this command, it helps you to guide where we have to go to see the analysis. So this is again the same table of descriptive that you have seen. And then if you go down, this is the test. It is again same table which has appeared previously also. This is the estimated marginal mean. So now you have to report this estimated marginal mean. It gives you the estimated marginal mean of interaction between this intervention and gender. So this gives you can have this table where there is a mean of placebo across male and female along with its confidence interval, diet modification along with male and female along with its confidence interval. So you will report estimated marginal mean taking first as a intervention, and then you will report this pairwise comparison. In this pairwise comparison also you will see here that it gives you the across. First it gives you the male and female, and then it makes the comparison of female placebo along with its diet modification and drug. Similarly, the female diet modification with placebo and drug. So it gives you that pairwise comparison. And if you go down, then again, this is the intervention and gender. So here, this primary thing will be the intervention. So it gives you both the values. Placebo group female, the mean value, placebo group male with the mean value and its confidence interval. Similarly, the pairwise comparison of this, the placebo, and then placebo female and male, the difference between that. Similarly, the diet modification female and male, the difference between that. And similarly, the drug female and male, and the difference between that. This positive and negative sign is only for like you are reducing I minus j or j minus I. So this you will report two simple main effect. Two simple main effect means it's the interaction. It gives you the estimated marginal mean. So you have to report this estimate table and you have to report this pairwise comparison. So you have to write first about the simple main effect of this one. This is the simple main effect of intervention, this gender. And if you go down, this is the simple main effect of this BMI, this across the intervention. So first, because in the command, you can see that first was the comparison of intervention and the second was the comparison of gender. So it is the 4 tables which you have to report, because you will see that the mean is different. Here you can see that the placebo female is 207 and placebo male is 211. And if you come up again, here you will see that again, this table will be the same because it is giving you the estimated marginal mean. So this estimate table and this table, this one, this will be the same. But this pair-wise comparison will be different. Okay, so you need to give one result of estimate and 2 pair-wise comparison in the result section. So if I go to the result section, so my question is, does the mean cholesterol level differs across the intervention? Does the mean cholesterol differs across gender? And is there any interaction between intervention and gender? So yes, this was again the same. If I go to the output, and if I see the descriptive, so this is the same thing, male and female overall, diet modification, drug, and total. So this descriptive is this. And then if you go down, test of between subject, this is the same table which I have explained that it shows you the test between the subject here. So this table we report here, we have reported this one, intervention, gender, and intervention, gender interaction. So now you write about that it was significant, that interaction. That's why you are reporting simple main effect. In the simple main effect, that table is not there. So it is missing. You include that table, or maybe we will upgrade this. So this table is not there. So you should have this table also with its 95% confidence interval. And then, because this gives you the estimated marginal mean, and then the pair-wise comparison. So 2 pair-wise comparison, right? And then this you will also include, and then ultimately you will write the interpretation. So in the interpretation also, here we can see that the two-way ANOVA was conducted, and again that QQ plot and everything you will include. And then you can write the similar, that there was interaction. That's why there was an interaction effect between the gender and type of intervention. So that's why this was statistically significant. Therefore, that analysis of simple main effects for intervention was performed with Bonferroni adjustment. There was a statistically significant difference in, this was, I think, of the mean of, this was cholesterol and cholesterol for females. This was not for the education, but this was for the gender. So similarly, this was for the intervention. For various levels of interventions. Similarly, this and then mean cholesterol. So this was the analysis and interpretation of the same 3 tables which we have discussed here in the output. So if I go back again to the presentation, and if I see this, maybe that all these commands, let me go to this one, and then so this we have written here, save option, residual, checking residual. So unsplitting, this is all the outlier, normality, and then visualizing the profile plot. This I have written post hoc. So I think let's not discuss this because I have not discussed this. So that estimate and pairwise comparison we use. So we report the main effect of gender, the main effect of, this was regarding the main effect. So that's all, everything is there in this simple main effect. That syntax file, that command is also there. So if you forget, you can see from these run syntax file.
Ma'am, can you just repeat after the syntax file what to do, because my net went out. I couldn't, I didn't see all the commands
Okay. So
after
that's
the syntax.
syntax.
Huh.
So if you see the syntax, so should I again run the syntax? Okay, I'll again run it because then you need to see it. So you go to this analyze, general linear model, univariate, and then there is an option of paste here. So if you press this, it will lead to a syntax file. Already this syntax is there, so it is another syntax which has appeared here. So in this, go to this EM means. So here the estimated marginal means gives you the interaction effect, but it doesn't give you the simple main effect of gender separately and simple main effect of BMI category separately. So what you will do here, you will add something. So what you will add, you will create one space and then you will add compare. So if you write compare, this compare will appear. In compare, you want to have simple effect of intervention, simple main effect, close the bracket. This I should be capital, the way that has been, so you see, the way you have labeled your variable. And then you have to compare, so write this adjustment. So this adjustment you have to do by Bonferroni. So if you press this adjustment, this red ADG will come, type Bonferroni here, close this. So this is one command for a simple main effect of interaction. Now you want similar simple main effect for BMI cat, not the BMI, but rather the gender. So now I will replace this intervention with gender. And then so this is my syntax is now complete. So this is again the same thing which is written here. So what I'll do, I have to run this command. So you can select this and then you can run this OK. So if you press this run OK by selecting all commands, then it will lead to a descriptive. Again, this is the same table which you have seen in the test between subject in the first scenario when we have used the systolic blood pressure. And then you have got the simple main effect of this simple main effect of this intervention. And then there is a simple main effect of gender. So this is the simple main effect of gender. And then this gives you the pairwise comparison. And then you can report it in your result. So this is the one which and then that's how you enter the table. So I have shown you that you will have this table and then this intervention, and then you will have one more post hoc. This pairwise comparison, there is a pairwise comparison of female diet, placebo and drug, and then there is again, there's a cross intervention, and then with that this table, when it has reversed the combinations. So like this table. If you go up, this table, when it has compared the placebo versus male and female, right? So that should be reported. So if you have understood up till this point, then I think any other confusion, I've told you initially that it will look a bit complicated to you because of the syntax command and because of that interaction effect present or not present, whether you should report simple main effect or you should report main effect, or the pairwise comparison, because there is two pairwise comparison. So based on that, you might find it a bit, complicated initially, but with the repeated thing, it should be okay for you. So if you have done up till this point, then we have not kept any separate exercises for today's practice, because that will be given to you in the evening. So you have to practice on the same data set and on the same question. So if there is no question, then we may open the breakout room. So yes, I think all of us are back to the main room. So I know that today's session was a little bit, I can't say, right? So it will take some time. Maybe it took us also to understand and imbibe the concepts. And still, I said in the beginning that we are still learning. There are few unanswered questions where we could not find a very valid answers for those questions. And we are still trying to find out. So maybe if I know that you people will have a lot of questions. So keep posting those questions and we'll try to answer. A good day to all of you.